All right, so I'm going to welcome you. This is a short lecture video on standard deviation and z-scores, and I'm going to show you how they're related to each other. So the first thing is I want to define what standard deviation is. And the easiest way to define that is to say that standard deviation is simply the average distance each data point is from the mean. So here I have a data set, and this is Major League Baseball player salary from 2012, I believe it is. And the average, and this is in thousands of dollars. So 8,500 equates to 8.5 million. So the mean for this data is it's about 3.3, which is $3.3 million. Standard deviation is 4.4 or $4.5 million. Standard deviation is pretty large. When you have a large standard deviation, that means that your data points are all over the place, right? So if you were to do a scatter plot, it would just be all over the place. If your standard deviation is smaller in comparison to the mean, then they would be clustered around the mean. So when you built a scatter plot and you'd be able to pinpoint the mean, all of the data points will be really close to it. So here's a scatter plot from Major League Baseball. And as you can see, they're not clustered, right? So they're pretty spread out, and that means that they're pretty variable. That means is that on average, each data point, so each one of these dots, is 4.5 or $4.5 million away from the mean, right? And again, that's pretty variable. So if it was smaller, they would be just tighter, and they're not as tight because the standard deviation is pretty large. I mean, it's larger than the mean. So how does standard deviation? So again, standard deviation, it's the average distance each data point is from the mean. So if I were to take each one of these salaries and I would subtract that from the mean, find the difference or the distance they are from the mean. So 8,500, how far is it from 3,281? 8,250, how far is it from 3,281? And I would do that for each one of these players, and there are 828 players here. And then I find the average of that. That's when I get my standard deviation. So it gives you an idea of how variable your data is. So the smaller the standard deviation, the tighter the data, the more clustered around the mean they are. The bigger the standard deviation, the more variable it is. And so your data points are going to be spread out. So how does this relate to z-scores? Well, what happens is that z-scores, or standardizing a data set, allows you to compare data points from different data sets. So for example, if I took a test in biology and I took a test in calculus and I wanted to find out which test I did better, simply comparing what I got on each test is not sufficient because I don't know what the mean is for each test. I don't know what the standard deviation is. But if I knew that information and I found the z-score, then I would be able to compare, and then it would be more significant that I would say, okay, I did better on the calculus test than I did on the biology test because the z-score was higher. And you had an example like this on the quiz, and I think it was question 9, I believe it was, with the art major and the theater major. So that allowed you to compare those two. Otherwise, you couldn't compare them because it just wouldn't make any sense. So again, standard deviation is average distance each data point is from the mean. And what the z-score does is that it standardizes a data set. And by that, I mean is that if I standardize a data set, then my mean is no longer, for this example, is no longer going to be 3.2 million, it's going to be 0. And my standard deviation is no longer going to be 4.4 million, it's going to be 1. And then that allows me to standardize everything. So what I'm going to do is I'm going to show you the z-score for Brandon Webb. So Brandon Webb's salary is 8,500 or $8.5 million. So what is his z-score? So we're going to go ahead and allow, we're going to do the formula, which is z is equal to x minus x bar divided by s, right? So it's 8,500 minus the mean, and I'm going to divide this by the standard deviation, and I get a z-score of 1.169272. So what does that mean, right? Well, what it means is that Brandon Webb's z-score, or his salary, is whatever the standard deviation is times 1.16, right? So 4.5 million times 1.16, that's how far Brandon Webb's salary is from the mean of 3.2 million. So I'm going to show you something. So if I take the 1.16 and I multiply times the standard deviation, I get 5,218.172. Now, if I add that to the mean, I should get back to my 8,500, and which I do. So the z-score then tells you how far Brandon Webb is from the mean, and in this case, it's 1.2 if we round up, right? So you can see that it's easier if we standardize it and we have a mean of 0 and a standard deviation of 1, rather than having a mean of 3.2 million and a standard deviation of 4.5 million. So I'm going to show you how to do that using Excel, how to standardize the scores. So you use standardize. The X will be your data point. The mean is going to be our mean for this data set, and then the standard deviation. So for Danny Herron, he has a z-score of 1.11. And they both have a positive z-score because their salary is higher than the mean. And so I'm just going to go ahead and do it so I can drag this and have Excel actually do it for me, as opposed to having to type it in for every single one. So I just drag this, and I'm going to drag this for all 828 players. And you notice that some of these players down here especially actually have a z-score that's negative. And the reason being is because this guy has a salary of 400,000, and that's way less than the average of $3.2 million. So these are the z-scores. Now, we can actually graph this on a scatter plot, and they should be very similar to what we got on the salary. So again, standard deviation, average distance from the mean, z-score. What you're doing is you're standardizing the data set from you're turning the mean to 0, the standard deviation to 1, and then it's easier to compare data values from different data sets. So here we have another example, right? So these are just some randomly generated numbers. And the mean for this is negative 0.06, and the standard deviation is 0.97. So that's pretty close to a 0 and a 1. And here's a scatter plot. And you can see they're really tight around 0, right? So the standard deviation is not that large. It's almost 1. So they're pretty close to the mean, which is, in this case, it's 0. So if we were to do this, the z-score, we would be turning this negative 0.06 to a 0 and the standard deviation to a 1. And so let's go ahead and do that real quick so you can see it. And it's going to be slightly different because, what is that, C2? And then my standard deviation would be D2. So this one has a z-score. Let me make sure I did that correct. So see, yep. So it has a z-score of negative 1.27, and the reason being is because this number is less than the mean, right? And I can do that for each one of these data points. I won't do it for the whole thing. I think I created 250 of them. And I'm just going to go ahead and do it for some of them so we can see the difference. So this one has the actual value is 1.8. The z-score is 1.97. And it's positive because it's greater than the mean. Again, this side here, the x's, have a mean of negative 0.06 and a standard deviation of 0.97. These z-scores, which we converted these x's into, have a mean of 0 and a standard deviation of 1. And so I hope this helps you to understand what standard deviation is and what z-scores are. When you get into the normal distribution, the z-scores will make a little bit more sense because normal distribution is the bell curve and everything is based off of a mean of 0. So I hope this helped. Any questions, just send me a message. Thank you.